eclipses are always a lot of fun, and that's how we went from cloudy skies to built up cumulus and then to clear skies. And we also had some other stuff in the sky last night. The moon heading on the home stretch to the eclipse, and there's the moon right there. And I can't remember if this was last night or the night before, but it was the last item I have on the camera there. So, full moon on the run up to the big eclipse coming up on the 21st. Okay, let's head to the charts and see what's going on right now. Again, we're using Digital Atmosphere here. This is a software program I wrote and which I'm working on an update tonight, and hope to get that update out over the past weekend, but the email has been so piled up that I've had to work exclusively on that. But we've got these planetary map functions, and that lets us do these really neat maps here. So what do we got? We've got southerly flow, and you can see there's a little bit of a trajectory from the southeastern U.S. and maybe a little bit of a dry line coming together in New Mexico. We've got 59 dew point there at Midland, 52 at Roswell, and so maybe a very weak dry line kind of in this area right here. But for that dry line to really take hold, what we need is a good regime of westerly or southwesterly winds in the desert southwest and lee side cyclogenesis in Colorado. And what we have right now, it's more of a ridging pattern. As you can see, we've got maybe a 1022 millibar high over the western Nebraska area right there. So that's pushing a lot of cold air southward. We've also got the southerly wind coming up from the Gulf, so somewhere in between there's probably a front. Let's see what NOAA thinks for frontal positions. And yeah, we can plot that too. Okay, so that's what they have for fronts. And this is a product that I've never really shown you before, but they have these frontal positions at WPC. Let me see if I can show a little bit of that right there. Weather Prediction Center at NOAA, that's kind of a centralized weather analysis desk. And they put out a lot of products showing precipitation and frontal positions. And they're going to match fairly closely to what you see here. Now these frontal bulletins, these come from their surface analysis charts, and there's actually a product here. I'll show you that also. If we go to troubleshoot data, there's a data type here called ASUS front data, and this is what the format looks like. And they've put this product out for decades, and it shows you the locations of all the highs, for example, the intensity, the latitude and longitude, and then they give you a list of lows, a list of troughs, and then the fronts itself. So that's how they do that at the Central Analysis Forecast Centers. And you can also draw on your own troughs and ridges and fronts and stuff like that. And basically what I've done in the program is I've emulated that. You just basically go into drawing mode, pick out your front, and then you can start drawing on your own front, and it uses the same bulletin type to encode the information. Okay. How about streamlines? Let's see what the streamline analysis looks like. That can give you a pretty good indication where the fronts are located. In the Central Plains, you see the northerly flow here converging with a southerly flow out from the tropics, so that matches up really well to the frontal location. And you can see the characteristic deformation zone right there. It's one of those patterns you've seen from textbooks, and that's where we have convergence along this axis, or actually that's divergence and then turning into convergence on either side right there. So lots of convergence in southwestern Oklahoma and southern Colorado, so that would be a favorite area for thunderstorm development, especially with these 60s dew points coming up into the higher terrain of Colorado right there. And while we're on digital atmosphere, let me see if we have any other products. Yeah, I guess we can show you the close-up view. And very high dew points there for Colorado, 65 there at La Junta and 58 at Pueblo. Okay, going to the regular chart lineup. What we see here is an enhanced area of forecast convection, so that almost precisely matches up that convergent area that we saw on that streamline analysis. So that's a very strong upslope flow, bringing very good moisture up to the high plains, and consequently we do have a few thunderstorm watches out for that area, and there they are. This is the one out for Colorado right there, and you can see plenty of thunderstorm activity. And for anybody who missed it, if you wanted to find out why they issued this watch, you can easily just go back to the mesoscale discussions, because usually there's one preceding every watch. So what I would actually do is click on the archived mesoscale discussions, and we're actually going to need the one for the 10th. And then somewhere in this list we should find the one that covers that area. In fact, it's probably this one here. And typically there's a fairly decent write-up of what they're forecasting, and it's got the name of the forecaster there. So if you want to keep track of their batting averages, you can definitely do that. Okay. And we also have some thunderstorm activity across Alabama. Looks like it's almost singularly located in Alabama. Just a big old disorganized MCS. And also a few thunderstorms there in Florida near Lake Okeechobee, out towards the Fort Myers area. NHC, I think we've lost Franklin. Yesterday we saw it moving across the Bay of Campeche towards Mexico, and that appears to be gone. However, we do have a couple of other disturbances. This one, we're forecasting an area formation in the next 48 hours off the East Florida coast, and then this other one here, looking for development northeast of Puerto Rico. So over the 5-day, this is how it's going to shape up. This area here, this could possibly graze the East Coast. And then the other area closer to Florida, we're just going to have to kind of wait and see on that. The GFS might pick up on that area development right there. Okay, the 250 millibar chart up at 34,000 feet. I didn't get a chance to colorize this. In fact, if anybody's curious how I do that, basically what I do is I copy the image, and then I go over to Paint Shop Pro, and what I have is a base layer that looks like this. You can see it's nothing but land masses and sea. So what I'll do is I'll paste the actual chart. Let me move these graphics around. Okay, so then I'll copy this chart to the clipboard, and then I'll paste this on as a new layer. And then what I'll do is I'll merge those. So it's kind of funny, I'm using a 20-euro program to accomplish this. So you can see I've got this control right here. And then what I'll do is I'll resize that to a more manageable size. Oops. Have to merge those. And then I'll resize those. And then I'll resize the canvas also, so that way I can scroll way to the bottom if I need to do that. And then it's good to go. Okay, then it's ready to view. So let me put that into the chart sequence. And then we have our 250 millibar chart. So what we can see is we've got kind of that weak Hudson Bay vortex set up in that area, so that's continuing the northwesterly flow. And this is a pattern we've been in since, I think, late June at least. And then we also have the very strong ridging across British Columbia. We can zoom in on that area. So, jet stream up in the northeast, up in upstate New York, about where we would expect. And it looks like some new jet formation in the Central Plains right there. So that's going to be augmenting the thunderstorms that we have in that part of the country. A rather wide band of 60 to 70 knot flow up in that area. The UCAR 200 millibar analysis showing a 90 knot jet from Topeka to Denver. So this is going to be the core of the greatest bulk shears. And by bulk shear, we're talking about the difference between surface winds and upper level winds. Typically that's measured up at about 6 kilometers, which is going to be about maybe 21,000 feet or so. But we can also estimate it in terms of from the surface to 200 kilometers. And we're assuming that the wind speeds at the surface are kind of light, so very likely the bulk shears are pretty high once you get north of I-40. 500 millibar flow does show the flow tapering off a little bit, back down to 20 to 40 knots. And then we have very weak flow at 700 millibars. So what this is going to mean is the likelihood of supercells is going to be kind of on the low side. So we're obviously going to still get some hailers in Colorado, especially if we have strong instability, but this isn't the kind of pattern we see with rotating storms with well-developed mesocyclones. And especially with a low-level flow, 850 millibars showing very weak and variable winds. There's just not much to really set up the bottom of the hodograph there. 925 flow showing just weak winds out of the south at 10 miles an hour at Dodge City. So what we're going to see here is just kind of light winds at the bottom of the hodograph in Colorado, and then weak mid-level flow, and then very strong upper-level flow. So that'll help ventilate the storms and allow for long-lived structures, but just not the rotation. Now, the potential temperature map does show a good setup for a front in Colorado. Some sort of boundary right there. We were seeing a front coming out of Kansas in this area here, but rather weak potential temperature gradient right there. The stronger one seems to be way down here. So I'm not sure what's up with that. Probably an older front now surging north is what's going on. So two boundaries, two fronts at work here in the Great Plains. And there's the net result right there, looking at the visible imagery. You can see those anvils streaming out from the Colorado storm, spreading downstream about 150 miles all the way to the Russell, Kansas, and Great Bend area. So that shows you quite a bit of winds aloft. Okay, taking a look at the chat. Let's see what we got here. We have Alex Front and David Moore. Got 97 degrees in the Metroplex. Sue M, limited battery left. Well, we'll be rooting for you there, Sue. Did I get the donation? I'll have to check. If it came in today, I have not yet looked at it. I think I went through all the email and stuff last night. So I do appreciate the donation, and I'm sure it's there, but I'll have to do another email pass here to make sure I get that. But thank you very much, Sue M. That is much appreciated. Ryan is talking about flooded southern Florida. He says, boy, did we get it today, 4 inches of rain. We have Burl H here and SPC Richmond. Ryan's mentioning tropical wave EV11 pounded Florida all day. Eddie W. is here and Fun with Tech. Justin Polium. And thanks to Justin, I appreciate the use of the images. Justin is one of the people that have kind of granted me kind of blanket permission to use some of his pictures and graphics for educational use here, so I appreciate that. And also Carl Berghoff has been very generous also. If anybody else has granted me kind of a blanket permission, let me know and I'll be sure to give you credit. I may have just missed it in my disorganization here. Mick, there in Australia, 18 Celsius. It's got a 64 Fahrenheit there in Australia. Alex Front saying hello, and Mick says winter has disappeared. And there is Carl. Ryan saying the tropical wave far out in the Atlantic showing promising signs of development. TD is in Central California looking to go up to that eclipse, I guess maybe in Oregon. Ryan keeping tabs on the wave, heading north of the Bahamas. Some comments about the music, very good. Carl was watching the hand analysis exercise. I guess that was from a few months ago. On the surface plot, the pressures are in inches, not millibars. It depends on the map. I vary between the two. That's probably a good topic for another production, and I have been thinking about doing another analysis exercise here coming up soon. Let me give you guys something else to look at while I go through the rest of the texts. I'm going to bring up GR level 2 here. Okay, GR level 2 coming up, and I guess we're going to look at the Pueblo radar. Okay, I don't have Pueblo in my list, so I'm going to just select it manually. Okay, and hopefully that doesn't affect the connection too much. It does have to load up about 2 or 3 megabytes before it displays an image. Okay, Alexi says, please don't forget to hit that like button. I appreciate it. Alexi also says, welcome to the new people, and yes, I'm right there with you. Thanks to all of those who are new to the stream. There's a lot going on in chat, and every production we talk about different material here. Okay, just scrolling down very quickly for the rest of the comments. Ryan says Franklin's expected to reappear on the Pacific side. Incredible resilience of these tropical storms blasting through this season, a sign of things to come. NOAA updated hurricane storm prediction this year. 5 major hurricanes over Cat 3 for Ryan's vicinity and 11 more named storms. Yeah, that should keep us busy. And what I'm thinking about doing is for the Patreon donors, I'm probably going to put up some special streams when we have hurricanes like making landfall. That way I can kind of toss something back for those of you who have contributed. Buoy water temperatures in the Gulf or in the Caribbean and Atlantic continues to show very high conditions. Yeah, sea surface temperatures are above normal, so that is kind of ominous right there. Carl says, type Tim Vasquez hand analysis exercise into the search bar. And Alexi giving me permission to use images also. I appreciate that very much. So I will definitely add you to my blanket list, and thank you, Alexi Pinkson Walsh. Okay, let's keep things moving along, and there's the storms there in Colorado. Upslope storms being fed from the east-southeast. And these are mostly multi-cells here. They might have some supercellular structure on some of the storms, at least temporarily, but these are mostly just hailstorms. And you can see the very high reflectivities here in the Johnson, Kansas area. And then the tops of these storms touching 56,000 right there in southwest Kansas. And then up at 29,000 feet, you can see the very high reflectivities, 60 dBz's right there, good core. So that's going to be hail at high levels. Good indicator of hail. Very purplish colors here from the surface, all the way up to about 15,000 feet there. And likewise, some of these other storms are probably putting down some hail also. So maybe we can take a look at a sounding. We'll maybe give Dodge City a try. The Dodge City evening sounding is looking like this. And we see some steep lapse rates in certain layers, like in the mid-levels right there. Very warm temperatures also at the surface. If we proceed from like 83 degrees Fahrenheit, our lifted parcel is going to be something like this. So it's kind of long and skinny, surprisingly, but Dodge City is at a lower elevation. So if we bring these parcels up a little bit higher, we're going to see probably a little bit more instability and maybe some cooler temperatures aloft. Since as we go northwest, we probably get to some of the lower heights. And also the very dry conditions aloft right there. That can be very significant in terms of severe weather. And that's also a good pattern there for release of potential instability. If you lift this part of the column, for example, lapse rates the latent heat will help warm that part of the sounding as it lifts. And when this other part lifts, it's going to lift diabatically, so it's going to cool at a little bit faster rate. And what that will act to do is it'll tend to steepen the entire diagram. So this is a good pattern in many respects for severe weather. And of course we also have the strong winds aloft. Let me see if I can bring up one more sounding in that area. I guess there's Denver. That's pretty far north, but we'll give that a try. Some fairly decent moisture for the high plains right there. If we proceed with maybe a 78-degree temperature, we get a lifted parcel, maybe something like that right there. Definitely some instability there in Colorado. And maybe some areas in Colorado where we have the moisture even more concentrated, that's going to push that theta E even further over. So I would expect there's probably a good theta E ridge in there somewhere. Let me see if I can find that. I think the SPC mesoanalysis site is pretty good for this. And what I'll do is I'll go to the theta E advection, and that'll show us the theta E field. And generally where we have the theta E axis, that's going to correspond to where the best storms are. And I can see the higher concentrations are in this area right here, Texas Panhandle all the way up to Colorado. It's a little bit affected here by the convection we already have in this area, but I do kind of see where we have a little bit of a theta E ridge in here. Let me back that up a couple of hours. Yeah, this is before storms got going, and we can see 370 Kelvin here for theta E's. This is a prime area. Good parcels here, and you can see how much better it is compared to Dodge City. So once you get a little bit further west, you're going to have a parcel that's it's going to look a whole lot better there on the soundings. The lifted line is going to be further over to the right, and that'll probably squeeze out a lot more instability than you otherwise would. Let me see if I can bring up the Cape, for example. Yeah, there's the mixed layer, lowest 100 millibars, and you can see that there is a bit of a max right here in southeastern Colorado. Go back a couple of hours, eliminate all the convection, and there you go right there. So much better in southeast Colorado compared to Dodge City where we looked at the sounding. So would be nice to sounding launch in there, but fortunately the models, to a certain extent, they're able to keep track of the fields in between. All right, we'll keep things moving along. Maybe we'll take a look at Fort Worth. So you saw how all the convection that we had during that time lapse at the beginning. We had a lot of cumulus developing, and you saw the formation of some stratocumulus layers. So we've definitely got some sort of inversion. And it's pretty weak, but there it is right there. Very weak subsidence inversion. And that was probably enough to keep us kind of capped. Let me see if that shows up a little bit better on the Shreveport sounding. Yeah, it looks a little bit lower. I think that's closer to what we have here. That altcumulus layer looked to be about 10,000 feet or so. So I think we had some towers building up into the deep troposphere, but there was a lot of stratification probably in that layer right there, and then things shut down. So not really ideal for convection where we're at, and no steep lapse rates in the mid or upper level parts of the sounding. But, you know, we were able to get some good time lapse out of that. Okay, let's head into the forecast. And here's our deterministic GFS forecast for the eclipse. Actually, we need to take that back a little bit further. There we go. 21st at 18Z, that's precisely at eclipse time. And the track of the eclipse, running about exactly like this here. So this preliminary look at the forecast suggests high pressure across the Midwest. A little bit of cool air advection coming down into Kentucky and Tennessee. So for points from maybe Nashville to Omaha, I think things are looking pretty good underneath that big high-pressure dome there. Gets a little bit more problematic as you get towards the Carolinas because it looks like we have a front located right through there. So near that front, we're going to have probably some precipitation, especially where it intersects the mountains right here. The Appalachians located right there, and maybe a few clouds out ahead of the front. And then on the high plains, we see a warm air advection pattern, but most of the zone is already warmed up. So I'm probably not looking for any overcast layers. Probably looking pretty good in the northern plains also. So I think we're essentially down to whether there's any high clouds in this area, and that I'm not too sure yet. The upper level patterns are looking like, we'll bring that up. I'm going to bring up the relative humidity field. So there's the forecast there. Looks like we have a little bit of clouds coming around the ridge there in Nebraska. But we're just kind of picking details out of the models. There's probably going to be a lot of change between now and then. We also see a little bit of cloud layers coming into the Pacific Northwest, and the models are showing more of a south-southwest component. And that's definitely bad because there is a correlation between southwest flow in the Pacific and cloud layers. So we're going to have to keep an eye on and see what that shows. But let's compare this to what the previous models had been showing. Okay, this is the current forecast. So you can see that southwest flow through the Pacific. So if we go back to the previous model runs, and while that loads, you can see the troughing off the coast and the ridge right there in the northern plains. We run this back, and this is yesterday's model, and you can see a huge change here. More of a flat zonal pattern, and not as much cloud material. So we're still not clear on what exactly is happening with the models. There's a lot of flip-flopping back and forth. You can see now we have a ridge over the Pacific Northwest and a trough around the Rockies. Going back to previous model runs further, 2 days ago it looked like this. This is kind of similar to what we were showing today. And then going back even further, a lot of flip-flopping around, and this is valid for the same time. This is at eclipse time. But like I've been saying, it looks like the models are kind of converging on the idea of there being a ridge in the northern plains. It seems like every single run has kind of gone for something like that. And it appears the mean position on that is somewhere right in the Dakotas and Wyoming. And then we'll take a quick look at the 500 millibar fields. Relative humidity here would correspond to maybe high altocumulus layers, like thunderstorm debris and deep layers of lifted moisture. And it looks like it has most of that in the Rockies right here. Looking pretty good for the northern plains and the Midwest. 700 millibars, looks like we have probably a similar picture. Looking pretty good for this area here. The models do want to carry a little bit of cloud material there in Nebraska and Kansas, and maybe that could be some debris from MCS activity back on the high plains. Maybe just kind of advecting eastward. maybe the remains of an old MCS. And let me take a look at the precipitation products and see what that shows. I want to see if the MCSs are kind of active around then during the previous night. So this will show the precip. And yeah, this kind of looks like the remains of an old MCS. Let me see if I can bring that back a little bit further. This is 252 hours coming up. So this is going to be about midnight. And yeah, it looks like some thunderstorms right there. Weak thunderstorms in western Nebraska, and then the next frame is noon the previous day. So, okay. So, you know, again, we're kind of nitpicking at the models, but there is kind of the scenario here of MCSs going up in western Nebraska, and then the debris fields moving into central Nebraska later during the afternoon. So we'll keep an eye on that and see what that is showing. But so far, looking pretty good for the Midwest and the lower Great Plains there. Then we can take a look at the North American Ensemble forecast. This is the copy of the Canadian. I'm sorry, the source of this is the Canadian and the GFS model. So this is the mean 500 millibar flow. And so we're kind of converging on the idea of troughing in the northwestern U.S. We're looking at a jet stream way up to the north in Canada, and aside from that, we can't tell very much. Definitely looks like there's going to be a subtropical ridge covering most of the southern U.S. And let me see what other fields we have here. Temperature is not going to help us out too much. Surface wind speed, that's not going to be a big help. Maybe the thickness, we'll take a look at the thickness and see what that shows. So thickness is showing a big thermal ridge all the way up into Montana and North Dakota, which is good. I prefer, you know, seeing the stronger gradients of thickness. I prefer seeing that up in Canada. We don't want that down in the lower 48 because that would create problems with isentropic lift and stratified layers. Thermal advection would be a big problem, and this is going to be associated with more of a late summer pattern here, so I don't see any big problems here. We may have trouble, though, in the Pacific Northwest. We'll have to see how this plays out, because there is a gradient here. Possible front down in this area. So I see a slight possibility that people would have to head a little bit east to get away from the clouds. However, there is a lot of uncertainty in the model forecast. You can see this purple zone here. This is indicating there's a lot of uncertainty still in the model forecast for the Pacific Northwest, but things seem to be a little bit more consistent in the central U.S. and the Midwest. So there we're looking for northwesterly flow. So, yeah, this is the thickness field, but this is implying kind of a northwesterly flow. Let me bring up the actual upper level flow. Well, that's 500 millibars right there. Yeah, I guess we don't have a true upper level map here, so we'll just have to kind of pass on that. But anyway, I do think things, so far, they're looking okay for the lower plains there in the Midwest, and then we'll just kind of have to see what happens as far as that possible area of storm debris there in Nebraska, and then that frontal system and troughing out in the Pacific Northwest. So we'll know for sure. We'll probably have a better idea. Well, not know for sure, but I think as we get towards the weekend, and especially early next week, things should start locking into place. And probably by Monday or Tuesday, we're going to have a reasonably good idea what's going to be happening out there for the eclipse. Okay. I'm going to look through chat, and while I do that, I'll bring up the radar. And let's see here. Alex Front getting a storm right there. Sue M is having to bail because battery is not staying charged. Blue skies around DFW today. Sarah Wood, they're expecting storms tonight in Indiana. Ryan's going to be in Asheville for the eclipse by Friday to scope things out. David Moore getting buffering on the eclipse forecast. Yeah, I might have been loading some frames there. Funma Tech just finished reading the weather analysis and forecasting book. Appreciate that. Weather analysis and forecasting book, that's available at weathergraphics.com, and that's written by myself. And I think that'll probably do it for tonight. So we're about 48 minutes in, and that is the forecast. So anyway, I appreciate you all watching the forecast. Thanks, and we'll see you tomorrow night. Have a good evening.